These are notes from Mel Ham's Math 110B at City College, section 7.2, trig integrals. First, recall the derivative of the sine function is the cosine function. The derivative of the cosine is negative the sine. And we have some identities from trig. We have sine squared theta plus cosine squared theta is equal to 1. If I subtract cosine squared theta on both sides, I get sine squared theta equals 1 minus cosine squared theta. And likewise from here, if I subtract sine squared on both sides, I get cosine squared theta equals 1 minus sine squared theta. First type of integral we want to consider is those that involve sines and cosine. Sine to the m power of x, cosine to the n power of x. The easier problem is if either m or n, or both, is odd. Then that's an easier type of situation. The harder situation is if both m and n happen to be even. Right, so we'll start with the easier case. Either m or n, or both, is odd. So here's number 1, sine squared x cosine cubed x dx. So the exponent here is a 2, the exponent here is a 3. That's the easier case because I have an odd number, 3. So what you want to do for the odd exponent, cosine cubed, is to write it as cosine squared x times cosine x. So I've written with sine squared x cosine squared x times another cosine x dx. So what I want to do is rewrite this part right here is a bunch of stuff with only sine x. This is stuff with sine x. And then if I have cosine x here, then I'll do a u substitution. Okay, well, we know that cosine squared x back up here is 1 minus sine squared x. So I'm going to rewrite this as sine squared x, there it is. And then instead of writing cosine squared x, I'm writing parentheses 1 minus sine squared x. And then cosine x dx. Now, all of this stuff here only has u, so if I do a u substitution, this would be my du. So u equals sine x, du equals cosine x dx. Then this becomes u squared, parentheses 1 minus u squared, and then cosine x dx becomes my du. And I'm just left with a polynomial. Distribute, and you get u squared minus u to the 4th. Fairly easy to integrate. U cubed over 3 minus u to the 5th over 5 plus c. Remember, we're doing indefinite integrals now, so you need a plus c. And then just change u back to what it was. So 1/3 sine cubed x minus 1/5 sine to the 5th x plus c. Final answer. Okay, number 3, you have a definite integral from 0 to pi over 2 sine to the 7th theta cosine to the 5th theta d theta. Here both the power on the sine and the cosine are odd. 7 and 5 are both odd, so again that's considered the easier case. Alright, so for instance I will change this so that there's a cosine theta left out. So I write sine 7th theta, cosine to the 5th I write as cosine to the 4th theta times the cosine theta d theta. So I want to have all of this stuff circled here to only involve the sine. Then I'll do a u substitution. Okay, and I have cosine to the 4th. Well, I can write cosine to the 4th as cosine squared squared. And now again I change cosine squared to 1 minus sine squared. So I've got sine to the 7th theta, parentheses 1 minus sine squared theta squared, cosine theta d theta. So now this expression here only has sine theta, so I'll do a u substitution. This will go away, and then again I have a polynomial. So u equals sine theta, du equals cosine theta d theta. This is a definite integral, so I'm going to change the limits. So theta goes from 0 to pi over 2, what happens to u? So I plug in 0, sine of 0 is 0. Plug in pi over 2, sine of pi over 2 is 1. So I'm going to integrate from 0 to 1, my favorite numbers to integrate. Alright, so now sine to the 7th becomes u to the 7th. And now I have 1 minus u squared squared du. And it's just a polynomial, a little bit of cleanup, but it can be done. So I'll square 1 minus u squared. So u to the 7th times 1 minus 2u squared plus u to the 4th. Distribute u to the 7th minus 2u to the 9th plus u to the 11th du. Okay, so that gives me u to the 8th over 8 minus 2u to the 10th over 10 plus u to the 12th over 12. Don't need the plus c because it's a definite integral from 0 to 1. Plug in 0, you get 0. Plug in 1, you have 1/8 minus 1/5 plus 1/12. Do the arithmetic. Common denominator is 120 and comes out to be 1 over 120. Mind you, on quizzes and tests, I do need to see all of this work. I will stop and say etc., but you should show me the arithmetic. Okay, ignore this thing. That was from the 7th edition. Okay, now for a couple of harder situations. What if I only have even exponents, like cosine squared or sine squared? Okay, so that's considered the harder scenario. Then you have to make advantage of these identities So cosine squared of theta is 1 plus cosine 2 theta over 2. Sine squared of theta equals 1 minus cosine 2 theta over 2. It says here to be memorized. At the time I wanted it to be memorized, but for you guys, you can put it on your formula sheet. Okay, so to integrate cosine squared, the trick is to rewrite it as 1 plus cosine 2 theta over 2. So there it is. Factor out the half. Integral of 1 d theta is theta. Integral of cosine is the sine. And then by the chain rule, since there's a 2 here, again, if I were going to differentiate, I'd multiply by 2. Since I'm integrating, I multiply by a half. So theta plus a half sine of 2 theta. Quick double check by differentiation. What's the derivative of this stuff? Derivative of theta is 1. Derivative of half sine of 2 theta is half cosine 2 theta times 2. That 2 knocks that out, and you get what you wanted, which is 1 plus cosine 2 theta. The 2 is already out in front and 1/2. Okay, so we're going from 0 to pi over 2. Plug in 0, you get 0. 0 plus sine of 0 is 0. Okay, plug in pi over 2 here. If I put pi over 2 here, I'm taking the sine of pi, which is also 0. So I have 1/2 times pi over 2. That comes out to be pi over 4. Okay, here's 11. Again, this is considered harder because both m and n, the exponents are even, sine squared and cosine squared. So both of these, I'll use their corresponding identities. So sine squared x is 1 minus cosine 2 theta over 2. Cosine squared x is 1 plus cosine 2x over 2. Multiply them out. 2 times 2 is 4. I factor out as 1/4. 1 minus cosine 2x, 1 plus cosine 2x. Well, that's like a minus b, a plus b. That's a squared minus b squared. So it's 1 minus cosine squared of 2x. But 1 minus cosine squared is sine squared. So I can write this as sine squared of 2x. And once again, I will use this identity. Sine squared of an angle is 1 minus cosine of double the angle over 2. So I have to double the angle 2x. So what's double of 2x? 4x. So 1/4 is in front. 1 minus cosine of double that angle, 4x over 2. That's an application of that right over there. Okay, yeah, I messed up over here. 1/4, take out the 1/2, it's 1/8. Okay, integral of 1 is x. Integral of negative cosine 4x is negative 1/4 sine 4x, again using the chain rule in reverse. The integral of negative cosine is negative sine. If I were to ask to differentiate this function, right here you would multiply by 4, so here you multiply by 1/4. And you're going from 0 to pi over 2. Plug in 0, you get 0, 0 here, sine of 0 is 0. Plug in pi over 2 minus 4 times pi over 2 is 2 pi. The sine of 2 pi is 0. So I just have 1/8 times pi over 2, which is pi over 16. Alright, so these are some of the notes for 7.2 trig integrals.